Hello and welcome back to Universe Sandbox 2, the game where I can do this and not feel too bad about it. Oh shoot, no, we need more firepower. More firepower! Okay, maybe the sun does not want... There we go. Okay, supernova. Good enough. Good enough for now. So, you may be asking, what are we going to be doing today? So we're going to investigate a few things when it comes to Universe Sandbox 2 physics. Okay, so today we're going to be pitting a few user objects up against each other, and on top of that, just doing some ridiculousness. So first off, we are going to do a classic battle, which has been done on this channel a few times during streams, but it's also always interesting to see who wins. Currently, it's 2-1 Spock Vopper beating Spook Vooper almost every single time. But let's see what the results are this time, just to see how consistent this game is. So what we're going to see is these are going to run into each other after I turn off their position lock, of course. They're both the exact same radius, so the game calculates them both evenly when it comes to collisions, and it's kind of random who wins. Occasionally, though, something very strange will happen during these collisions that are pretty much the same, and we're going to look out for that. So here we are, we have our two planets, and they are going to collide in 3, 2, 1. Okay, maybe that counting was off, but I want to get a good shot here. There we go. So we get a nice explosion, a ton of material flies out, and the question is, which side? Okay, it looks like Spock Vopper actually just disintegrated. Like I said, strange things happen when you do this. So it appears that that wasn't even close that time, and Spook Vooper won fair and square. Which is completely the opposite of what happened during the stream. Last time it was a very, very long battle that came out very close in the end. So next up, let's go to our next thing we're going to do. If we go, new. So what we're going to do is we're going to simulate what we did a while ago. We got two planets. Put them very far apart from each other, and we made 150 million kilograms, or moons, 50 million moons. And we made one of them 15,000 moons. And the result of this was actually quite odd. So let's see if we can do that again. I'm just seeing if things are consistent, because we've had some very strange things happen in the past. But I guess consistency is a interesting thing. Okay, so as we can see, it just absolutely annihilated itself. Turned into a giant blue ball, and what is left over? A fragment turned it back into a star again. Not what happened last time, but that was still pretty interesting. I don't know why those numbers caused that, but I think it's just on the verge of being a star, and then adding the extra mass breaks it apart, and then when it all forms back together, it's just enough to make it back into a star again. Once again, it's weird. I can't completely explain it, but some things are better left unexplained. So what we're going to do now is yet another simulation, because that's kind of what this game is. It's a simulation game. And we are going to put, because I actually had a request for this, we're going to try putting a binary star system in the center of the solar system. So this is going to be slightly challenging because they're going to want to move. So sun, here's one of them, here's the other one of them. Yeah, see, they're going to move, which is a huge problem for us. I think that's the only way they will stay binary. So I'm not sure how we can do this. Okay, what we could try is, because everything's orbiting the sun, instead of doing that, just add the second one. See if everything follows. Not really. Almost, the sun almost intercepted Mars there, but this is just going way too fast for the solar system to catch up. So, there is yet another way we can pull this off, which is to slightly move the sun until we get it to the velocity we want. So if we get a motion, we start turning this up. Not enough to destroy the solar system, but enough to move it. So, giving it some time, we will begin to see the actual entire solar system moving soon. But we have to get up to a few kilometers per second before we see that. Currently, we're at about 200 meters. And now we're in the kilometer range. So we can now see the sun moving. Now we have to let the planets acclimate to this so that the sun doesn't just run away from them. And they seem to be doing pretty well with this right now. So let's increase the speed a little bit more. Let's try doubling it. Here we go. That's working. Tripling. Okay. So we're slowly accelerating the solar system. Now, the further planets are not going to like this. The close ones, at least, are going to go along. And we need to get this to about 10 kilometers per second, I think, to pull this off. 6, 7, 8, 9, 10. No, are we losing Earth? No, there we go. Now everything's orbits are absolutely off, but technically it's still the solar system. So I think we can actually pull this off now if we put the second star here. Oh no, that's much faster. How fast is that? Over 100 kilometers per second? Nope, I cannot pull that off. That was an attempt. It did not go well, and you know, we'll just end the attempt. There we go. Great supernova to vaporize the entire solar system because of our failures. Collapsing moons. Oh, I've been on this simulation before. Actually, let's look at the result. It should result in a, well, planet-sized object. But it is a nice few explosions, a bunch of material flying out, and overall, a bit of destruction. And there they go. So something we're going to experiment with, which I've actually been meaning to do for a while, was we have seen many experiments where we have a bunch of planets which, well, 2 planets which both have the Roche limit. They're very close together. But what we haven't done before is have more than 2. What if we pull off having 4 Earths in a square, pretty much equally distant from it? Yep, that was dumb. I admit it, that was dumb. I have to have the game paused when I do this. Okay, now we get these, and we position lock them. Or we position lock them one at a time. Boom, 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 and we're going to see their effect on each other. Are they close enough for the Roche limit to take place? That's the first question. I think they are. They may not be. Any particles coming out? No. That is fine. We'll just go to edit. We're just going to move them in a little bit. We'll move it in 3 squares this way and 3 squares the other way. 3 little squares, that is. If we're here and here. I think I went a bit too far there. It's fine. We'll move this in one more square. We'll go 4. And then this just needs to go in the center of that. Is that in the correct location? Yes, yes it is. So let's see how this works out. The Earths actually did heat themselves up to the point where their oceans blew it away. It appears that the rush limit still isn't kicking in. So, we need to get closer. Let's just go real close.
No, I'm dying.
A few sneezes later. Now, if we move these really close, we should get something. It may not be a radical change, but it'll be a change nonetheless. So let's actually just put these on corners like this. This, and this. There we go. Look at that. Oh, now they're heating up. Well, there we go. So that's the effect you're looking for. So it seems that they're all going for the same, because as they give it more mass, it gets more power over them. Now what we can do is we can actually flip this by giving these guys their mass back. And Earth, boom. And this one is just kind of doomed. But not anymore, because we can go in, bam, Earth, boom. For some reason, they just really like that corner one. They didn't even go for each other at all, other than that one. So they're just going to continually give that material. This one is losing it very quickly. Jeez. Feeding the enemy. So what we're going to do is we're going to see if we increase this Earth to the point where it's bigger than the other one, if it's the one that all 4 choose, or all 3 of the opposing ones. Or will this one go to the one adjacent to it because it's closer? Will they trade it all the way down? Will it go from here to here and then here to here? No, it seems like these two are just getting bigger. The other two are just feeding them. And they aren't messing with each other. Oh, now this one is, even though it's bigger, this one is taking the damage here. So if we zoom in here, here's our tiny little Earth because it's been ripped apart. Let's give it a huge advantage. Let's go towards... Oh shoot, that didn't actually do much, did it? These must have a lot of mass, or just a low density. Oh, these are 5 Earths. Okay, I see. We can shrink them a little bit and see the results. That's not the one I meant to do, but that's fine. So if we turn this down, let's see what happens now. This just completely exploded. This just completely exploded. These two are gaining so much mass they're actually about to touch. And one of these is going to lose, which is that one. And this is now ripping itself apart. What? This tiny thing can't be doing that. Well then. That's interesting. Huh. What if we did an experiment before where we had a black hole and it was very small, a small black hole, and it was right off of Earth's surface, which caused it to rip apart. We are going to, we're not going to do something that I'm planning for another episode, but we're going to try this. We're going to go towards about the same distance from the black hole next to each other, and we're going to see the effects on both of them. There we go. We just have to zero velocity the Earths. Or position lock them. Toggle everything, and let's see what happens. So as you can see, the black hole is facilitating the transfer of material from one to another. Anything that's ripped towards the black hole and actually misses it is being flung directly into the other Earth, and not slowly either. These things are being flung at... where is our velocity? 5,000 kilometers per second. Actually, 100th of light speed they're being thrown at, which makes it a very viable weapon. These things get accelerated very, very quickly before then crashing into the planets, which, if someone wanted to make a weapon in outer space, this would actually be a pretty accurate way of doing it. Actually, the black hole itself, I didn't position lock, and it's going back and forth between the two planets. It cannot decide which one to go to. Or did I position lock it? No, I didn't. It's just standing in the middle, it doesn't even care. So we can just see that these two Earths are staying practically the same size because most of the material is just being hurled at the other one. They're mutually sharing each other's materials, although now they're starting to take a ton of damage. Probably because the black hole itself is gaining a bit of mass. But that is quite a bit of destruction we got there. And they're just going to continue getting ripped apart. Fun. Let's delete them. Let's delete the black hole. And since everything's going towards the same spot, technically they should all... Whoa. Whoa, they all just died. Okay, well, they're all gone now. Interesting. Well, guys, I think that's going to do it for that video. Thank you for watching. Leave a like and subscribe if you enjoyed that video. I do have other things planned that are a bit bigger and more exciting than this one, but I just had to go through a few things. And yeah, before we end, let's look at the classic, the great, the no, I can't find it. Come on, come on. Earth and Many Moons. There we go. This is classic. Great destruction of Earth. And there it goes. See you all next time. Oh shoot, that's not the button.